We're glad that you can join us and be a part of us. Make sure that you stay for our session, but if you're not able to, the sessions will be recorded and will be available on the National Agriculture in the Classroom website very soon following this webinar. During this session, make sure as participants, if you have any questions, go ahead and type those in the Q&A feature, and I will work as your host. I'm Denise Stewardson. I'm the director of the Utah Agriculture in the Classroom program, and I will make sure that I work with Andrea, our presenter this afternoon, to make sure that we get your questions answered. So again, just use that Q&A function on Zoom here. I'd like to introduce to you Andrea Gardner. Andrea is an education specialist for the National Center for Agricultural Literacy. Prior to this position, she was a high school agriculture science teacher. She's the author of numerous lesson plans on the National Agricultural Literacy Curriculum Matrix. And if you've used that, you know how prolific she is and how awesome her lessons are. And in addition to being a curriculum writer, she also provides professional development opportunities for teachers nationwide. So Andrea, thank you very much for being with us this afternoon. Following Andrea's presentation, I'll have a few closing announcements, so stick with us. But Andrea, the time is now yours. Thank you.
Awesome. Thanks, Denise. We're to the end of the day. We hope you guys have had a good day and that we end this off well with some information to learn about climate change and agriculture. We're going to share some resources today. I'm going to share some resources today that are going to be applicable to secondary science and geography classrooms. I'm going to add to the chat here a link where you can find all of these lesson plans. They're on that curriculum matrix, and I've got them grouped together to cover everything we're going to be introducing in this session. So if you want to go ahead and click on that link, if you're in a desktop where you can have more than one screen, you can look at them as we're talking. If not, save that so that you can access it later. So I want you to just look at these pictures of foods and think of the things that you buy at the grocery store on a regular basis and ask yourself where it was grown. Where did it come from? Where was the farm that grew food? If we were in person and if you were in your classrooms, you can print out these cards and send your students on a scavenger hunt at the grocery store to figure out where they were grown and where our food supply comes from. And something that's very fascinating about our food supply is that it comes from all over. Most of our food, a lot of our food, depending on where you live, travels a distance to get to our plates and our tables and grocery stores. So we're going to be exploring a little bit of why that happens. And how climate impacts our food. So we're going to do a little bit of a quiz, and if you can pull up the chat feature, that would be great. You're going to be needing it here for a minute. We're going to do a quiz.
Andrea, I'm not sure our chat. Let me make sure that people can access that.
Okay.
Katie, you want to make that accessible?
Yes, it should be on and working.
Great. Thank you so much. Go ahead, Andrea.
Yeah, thanks. Okay, so I want to know if you can name a food just by seeing where it comes from. So I'm going to show you a series of maps. And in the chat, I want you to just throw out a guess of which food you think is represented by that map. Okay, so here's the first one. So one of these blue dots equals 500 acres of this food crop. What do you think it is? Again, just throw out your guesses in the chat form. 1 dot, 500 acres. It looks like we have almost all right guesses. The correct answer is apples. Okay, so this is the place in the United States, even though apples are grown in every state, this is where the most apples are grown in the United States. Okay, how about this one? 1 dot equals 1,000 acres of this crop. All right, we've got some good guesses, some correct guesses. It is potatoes. Good. How about this map? 1 dot equals 3,000 acres of this crop. And you guys are right. Again, it's rice. Okay. Another map. This one's a little bit tricky. What do you think this one is? 1 dot equals 10,000 acres. Haven't seen the right. Yes, there it is. Okay, this one's a little bit tricky because this map is actually soybeans, but a corn map would look very, very, very similar. So if you put soybeans or corn, you've got the idea, but this technically is soybeans. Okay, next map, a little bit different, but these are the 3 states where this food is grown. And orange is the correct answer. Okay, 1 dot equals 10,000 acres of this crop. Okay, you guys are right on, it's wheat. So just another little tidbit to add about wheat. This center region of our country is known as the breadbasket, just a nickname, because it has rich soil and it's ideal in an ideal climate for the production of different grains. So we're going to hang on to that information for a little bit later on in the workshop. But what we're gathering from this information is all crops are not grown in all 50 states. So if we can go to the grocery store, and probably most of us have a local grocery store that has a large variety of fruits and vegetables, berries, potatoes, apples, a large variety of foods that were not grown in the state where we live. Okay, why? The answer is climate. So we're going to be talking a little bit about how food and climate are connected. So the first thing that we need to understand, climate change is a little bit of a socio-science topic. When we presented this at the in-person conference in Saratoga Springs, we had some really good discussion with teachers, especially science teachers, about teaching about climate change in their classrooms, because it's a topic that has, like I said, it's socio-scientific, it has some political influence as well as different social influence in addition to the science. So it can be a complicated topic to cover in the classroom, but what I want to do first is cover just the basics of climate change and the carbon cycle. So the carbon cycle is taught in most science classrooms from middle school on up. And I want to just spend a little bit of time on those basics so that you have an idea of how this is contextualized in agriculture. So the first thing I want to show you is an e-magazine that we have. If climate change is brand new to you or your students, this is found in the lessons. And I'm going to go right to, let's see here. I'm going to pull it up. Okay, so you'll find this link in the lessons if you use the URL that I shared in the chat. But this is what the Climate Change Phenomena e-magazine looks like. It's something you can share with your students. It's got labs in it that they can click on. They're going to be learning how that we can connect carbon, climate, and weather with our food supply. So how are those topics integrated? So I'll just show you the other pages. How does climate impact our food supply? It talks about crops and the different specific climate and weather conditions that they prefer. Talks about carbon, what it is, how it moves from one sphere to another. And then it gets into what actually climate change is, what's causing it, what are greenhouse gases. Again, there's videos integrated in with it. This is a really great tool that you can use in your classroom or even as homework if you'd like, that you can use that. So that gives you some basic information. And if I go back to my presentation. We'll go on to the next part. So each of these tools that I'm going to be using here to talk to you about the carbon cycle are all found within the lessons. But the basic foundational science of the carbon cycle is that on our Earth, we have 4 different spheres. Okay, we have the atmosphere, which is the air, the biosphere, which is living things, the land, which is the lithosphere, and water, which is the hydrosphere. So the carbon cycle is when carbon is moving from one sphere to another. Okay, in its very simplest definition, when carbon moves from one sphere to another, it's called the carbon cycle. Okay, and we can be talking about elemental carbon, carbon dioxide, or methane. Those are carbon in different forms, and that'll come to play a little bit later. So here's a way to explain the carbon cycle in a linear fashion to your students, just as a kind of to build those blocks in the beginning to help them understand. So if we are talking about fossil fuels, that is taking carbon from the lithosphere or the ground and moving it to our atmosphere. Okay, so as we pump fossil fuels out of the ground and use them to fuel our cars, that is moving carbon from the lithosphere to the atmosphere. Okay, deforestation moves carbon from a living thing or a tree to the atmosphere. Okay, digestion from cattle and other ruminants is moving from the biosphere to the atmosphere. Okay, and 3 other cycles, photosynthesis moves carbon from the atmosphere to the biosphere. Respiration moves carbon from the biosphere to the atmosphere. And the biosphere, or decomposition, moves carbon from the biosphere to the lithosphere. Okay, so hopefully just those direct arrows, you can kind of figure out where carbon is moving throughout the cycle. You'll notice the ones on the left are outlined in red and the ones on the right are outlined in blue. That was specific because the processes on the left are mostly human driven and the ones on the right are mostly natural cycles. Okay, so that's something important as you build on your knowledge about climate change to understand that these processes happen naturally and others are enhanced by human activity. Okay, so if we look at this in a little bit different format, here we still have the same processes: photosynthesis, respiration, diffusion, weathering, decomposition. We look at this carbon cycle. These are all naturally occurring processes. The diagram looks fairly balanced, right? You know, we have carbon moving in every direction. There's not really a heavier side than another. Okay, so these are natural processes. But now if we were to look at the human-induced processes, what do we see? Do we see that carbon is equally distributed? Or do we see that there is an imbalance? Okay, we see that there's an imbalance here. So we have a lot more carbon moving to our atmosphere due to human activities. Okay, so this, again, we're just building a foundation. The carbon cycle is the science that explains climate change. And those are the processes that move carbon throughout our Earth. Okay, so the question is, where is agriculture within the context of climate change? And if you were to spend just a minute to think about that, where is it? Are we affected by climate change as agriculture, as farmers, as food processors? Okay, or does agriculture contribute to climate change? So if we really spend some time thinking about that, we need to recognize, and this is part of what ag literacy is not necessarily, is understanding where agriculture is in the scheme of, or in the context of climate change. So agricultural practices do contribute to greenhouse gas emissions. It's important to recognize that. But we also need to recognize that agriculture is vulnerable to the impacts of climate change. So if you think back to all of those foods and where they were grown, what would happen if in the next however many years the climate changes and it becomes too warm in Idaho to grow potatoes? Potatoes like cooler weather. What if it becomes too warm there and we can't grow potatoes there? So that's where the context of climate change is. Something that if we were in person and had time to really discuss, but if you would kind of think to yourself, one of the challenges that a lot of science teachers find in teaching about climate change is there's a lot of doom and gloom to it. There's a lot of just scary, the world is gonna, we can't keep up with this and this is bad and we have to change. Like there's a lot of gloom that comes with teaching about climate change. But when you use these tools to contextualize it within agriculture and within our food supply, it becomes a much lighter topic. It becomes much the facts in a problem-solving way and in a little bit brighter way. Okay, so let's keep moving on a little bit here. What are the environmental impacts of food and agriculture? Like I said, to be agriculturally literate, it's important to understand that food and agriculture does contribute to climate change and to the impacts in our environment. We also want to keep in context exactly how it fits, as well as what we're doing to improve that. Okay, so there's greenhouse gases, we use land, we use fresh water, some water is polluted, some biodiversity is lost. These are all different impacts of our agricultural system and what it takes to produce food for a growing population. Okay, so within the topic of climate change, one big topic is that of cattle and climate change. If you look at headlines, there's frequently things about cattle and how they are damaging the planet. Should we stop eating meat? Should we decrease our red meat consumption? There's a lot of headlines out there. So the question is, what's the scoop? How does it really fit? What are the facts? Let's just explore just a little bit. This lesson is in the collection of lessons that are included in the chat URL that I shared, but it's called Carbon Hoofprints, Cows and Climate Change. Now that's a little bit of a play on words for carbon footprint, except we're talking about hoof prints. But we are going to talk about what makes cattle different. Okay, so cattle have a ruminant digestive system, which means that they have 4 chambers in their stomach. That's part of that is their ability to digest feed that humans or other monogastric animals cannot, which is kind of a whole nother topic on its own. But something unique about this ruminant digestive system is it creates a gas called methane. Methane is one of the greenhouse gases. And we'll learn just a little bit more about methane, but through this lesson, students are able to start using science to answer questions about cattle and climate change. So is it true that cattle produce more greenhouse gases than the transportation sector? That is a statement that is made commonly, and a misconception that students are able to research through this lesson. Okay, another statement to address is cattle have negative impacts on the environment. Is that true or is that false? And what context can we fit it in? Okay, feeding cattle to produce meat is a waste of resources. We should be growing food for humans. How can we respond to that? Okay, how can we explain that in a way that helps people understand a little bit more about our food and where it comes from? Okay, so the unique thing about cattle that's different from other greenhouse gases is the fact that they produce methane. So it's not carbon dioxide, it's methane, and methane is more potent than carbon dioxide, but there's a little bit more to it. And we're gonna watch this video. Denise, let me know if the sound doesn't work, but I think it will.
What if I told you that cattle could be part of a climate solution? That's interesting, right? Well, it's true. And it's because of how methane works. Let me explain. Cattle emit methane, which is a strong greenhouse gas. And we need to make sure we're not emitting more methane. But if we can decrease it, then good things can happen. Methane is a greenhouse gas emitted from various sources. There's fossil fuel extraction, wetlands, and ruminant animals. When we measure methane's impact on the climate, We do so by comparing it to carbon dioxide, which is the most abundant greenhouse gas in our atmosphere. But the way we've been comparing the two climate pollutants doesn't reflect how they warm the planet. And if we're talking about a warming climate, then we should measure greenhouse gases by how they warm, right?
If your question is, how do we reduce warming? Then the answer is yes, we have been looking at methane incorrectly. We want to know what the impact of a methane reduction is on warming. And for that, CO2 equivalence is a totally wrong unit.
Current standards say 1 molecule of methane is as strong as 28 molecules of carbon dioxide over 100 years. And that's true. But methane doesn't live for 100 years. It's a short-lived climate pollutant, staying in our atmosphere for about 10 years before it's destroyed, meaning it's not causing warming for hundreds of years. Carbon dioxide stays in our atmosphere for 1,000 years, building up and continuing to warm long after it's emitted. Methane from cattle is also part of the biogenic carbon cycle, which has been around since life began. As part of photosynthesis, plants capture carbon dioxide from the atmosphere, absorbing the carbon and releasing the oxygen. That carbon is converted into carbohydrates in the plant, which is then consumed by a cow where it's digested and released from the cow as methane. After 10 years in the atmosphere, that methane is broken down and converted back into carbon dioxide. These carbon molecules are the same carbon molecules that were in the plant the animal ate, which was pulled from the atmosphere by the plant and is now back in the atmosphere. It's recycled carbon.
Biogenic carbon is different because it's going through a cycle. That's very different from fossil carbon, which goes through a one-way street from the bottom up into the air. If we were to keep our herd size constant, then that would mean that the amount of methane produced by our livestock and the amount of methane destroyed balancing each other out, meaning no additional carbon added to the atmosphere, and that means no additional warming.
Methane from cattle is considered a flow gas because as it is emitted, it is destroyed. Conversely, carbon dioxide from fossil fuels is a stock gas, which means it's stockpiling, or in other words, building up in the atmosphere. Carbon dioxide emitted today is added to the carbon dioxide emitted yesterday, which was added to the carbon dioxide the day before, and so on. This isn't a cycle. It's a one-way source of warming. The good news is, if we manage to reduce methane from cattle, such as with additives or digesters, we can actually generate short-term cooling. This is significant as we try to keep global temperatures from rising past 1.5 degrees Celsius.
What gets me the most excited is that if we reduce methane from, let's say, cattle, then we are actively pulling carbon out of the atmosphere. That's almost as if you were to store atmospheric CO2 in the ground. If you reduce methane from cattle, you pull carbon out of the atmosphere, and that induces global cooling. Can it be done? It can be done, and it has been done. Here in California, for example, we have been able to reduce methane by 25%. The way we reduce this 25% methane in California is through manure management changes. If you reduce methane, you induce a strong cooling effect. So meaning cattle be an important part of the solution to reduce our overall impact on climate.
Rethinking methane allows us to focus on climate solutions, both in the short term and long term, while still working to feed a growing population. But it'll take farmers and ranchers, regulators, and researchers working together to do so.
Okay, I just felt like that was a really powerful way to explain the difference between methane and carbon dioxide, and also to help. I mentioned this earlier, but I'm going to say it again, that being agriculturally literate isn't to set aside climate change or to think that agriculture isn't contributing to it. To be agriculturally literate is understand that agricultural practices do have impact on our environment, and we do rely on our environment to produce our food supply. And the way that we use that information is how can we make it better? If you're interested in this topic, I highly recommend following Dr. Frank Mittliner right here. He works for UC Davis and has done a lot of research on cattle and the environment. Has some really good educational tools and videos. You can find him on Twitter as well as lots of YouTube videos. But there's some really, really cool research going on and looking at ways that we can improve, meaning decrease our environmental impact of producing our food.
What if I told you that?
Okay, so I want you to go back to the beginning when we were looking at those maps and remember the breadbasket. And like I said, when we put climate change in the context of our food, do you think that we could ever grow bananas in our breadbasket? This is the phenomena lesson of, it's a middle school science lesson that uses NGSS phenomena to explore climate change. And as students learn where their food comes from and why it was grown in a specific climate, they start asking questions like, could bananas ever be grown in our breadbasket? Now, most of us probably know that bananas are grown in tropical corners of the world. Here's a map for you. There are a few places that bananas are grown in Hawaii and Florida, but commercially, all of our bananas come from mostly Latin and South America. So do you think bananas could ever be grown here? So this is a question that you can present your students through that middle school lesson as they really just start thinking about climate and climate change, because that's when they're going to be able to step up their questioning and step up their knowledge of science to start saying, okay, is it all doom and gloom? Is it all just, we're not going to be able to grow our food? Or are we going to need to change perhaps the areas where our food is grown? Okay, so with that, I want to introduce the concepts of climate smart agriculture, which I saw one comment talking about cover crops in the chat, and that's exactly what we're going to be talking about a little bit, is some of the climate smart agricultural practices. So there are researchers and scientists and farmers working around the clock, some of them, that are looking for ways that we can change and improve our agricultural practices and our farming practices to be more climate smart, to have less impact on the environment. So Dr. Mittliner's one that I mentioned with cattle, but all areas of agriculture have it. So I want to introduce climate smart agriculture. I'm going to do it with this graphic. So there's 3 goals that we have in climate smart agriculture. The first is to increase productivity. Okay, so producing food, fuel, and fiber for our world requires the use of natural resources, and it comes at a cost to our environment. Okay, we need water, we need land, we need arable soil, we need soil nutrients. All of those things are provided by our earth and can be used up too quickly. So if we increase the productivity or the efficiency of our farming practices, our overall impact on the environment is less. Obviously less in comparison to the nutrients that we are producing. So we could count calories, we could count protein, however we're using that measurement, but increasing productivity. Let me give you an example, kind of going back to cattle. So this is a map that shows us the carbon footprint of US beef. Or it gives us the carbon footprint of beef across the world. So if we look at the green is the lower carbon footprint, purple is the highest. Okay, so the United States is in the green area. And then if we look throughout the world, in India and parts of Africa, that's where the carbon footprint is higher. Okay, the reason for this is because cattle production in the United States is much more efficient than other parts of the world. So for example, I read a statistic that one dairy cow in the United States produces the same amount of milk as, say, 8 cows in another area of the world. They produce more milk, we have better genetics, we have better nutrition and feeding. So if one cow produces a set amount of greenhouse gases, but produces a large amount of food, then its environmental impact is less. Okay, so one way to promote and to practice climate smart agriculture is to increase the productivity of whatever we're growing. So this was an example with cattle, but the same could be had in other commodities as well. Okay, so the second goal is to enhance resilience. So regardless of what kind of changes that we make, even if we could make a 180-degree turn today on every single practice that causes global warming and climate change, we would still have the consequences of our and human impact on our environment. So it's ahead of us, if that makes sense. So regardless of what changes we make in the future, we still need to be resilient. We still need to find ways that we can adapt to a changing climate. So one example would be, can we plant, can we breed new plants or new varieties of plants that are drought resistant? Okay, those of you that live in areas of drought right now, I'm one of them, and I know lots of you are tuned in as well. Can we breed plants that need less water so that they can be more resilient in a drought? Or how about rising temperatures? Can we breed potatoes that can grow in warmer temperatures? Okay, so see how that fits in there. So that's a second goal of climate smart agriculture, is enhancing resilience. The third goal is reducing emissions. So I'm giving you an example of a tractor, and here you can see a fairly large field. That tractor, whatever practice it's doing, whether it's planting or spraying or harvesting, needs to burn a set amount of fuel to move throughout the field. But could we reduce our emissions by reducing our fuel use, or by making it that it has half as many passes to make it through the field? Is there something that we can do to reduce the amount of carbon that is released in the air from that machinery? Okay, that's reducing emissions. Okay, so inside this climate smart agriculture lesson, there are climate smart agriculture cards, and here's an example of one. There's 10 of them that show you different, or shows your students different climate smart agricultural practices. And I'm going to go to the lesson to show it to you. It is. Okay. Okay, so this is what the climate smart agriculture cards look like. You print them front to back, and each of them has a climate smart agricultural practice. So the first one is no-till and minimum till farming. What this is rather than completely tilling and plowing fields, they've created equipment that can plant seeds directly into the ground without tilling it, and that because tilling releases carbon into the atmosphere. So that moves carbon from the lithosphere or the ground into the atmosphere. So if we use no-till and minimum till farming practices, that decreases carbon emissions. So your students will read about it and then circle which climate smart practice, and sometimes there's more than one, which goal it achieves. So this one would be reducing emissions. Okay. Another one that was mentioned is cover crops. Cover crops are crops that are planted in between crops that aren't necessarily for, they aren't for harvest, like they're not an agricultural commodity, but they help to increase the biodiversity of soil, they help prevent erosion, and just improve the overall health of the soil. So they enhance resilience, and you could also, they potentially increase productivity as well. If the soil's healthier for the actual commodity crop that's grown, then they're going to have better productivity. Another example, I'll go through these kind of quickly, but diverse crop rotation. So how does crop rotations help? Precision agriculture is technology that's used to apply precise amounts of fertilizer and water to crops. So you're increasing your productivity while reducing your inputs using technology. Selective breeding, forage and biomass planting, manure management. Dr. Mittliner, they introduced briefly the manure digesters that create biogas and how that helps the environment. So anyway, there's several here that you can look through, but what your students will do is research some of these and find the climate smart practices that we're using in agriculture. Again, it's kind of an exciting thing. It's kind of something that it is new, and they're not brand new, but it's just something that they can really start to understand that a lot of research is going into this and a lot of effort, because we need to establish agricultural practices that are good for our environment and continue to have our environment provide our food and fuel and fiber. Okay, so speaking of manure management, here's another lesson. It's called Pig Power, Creating Biogas and Renewable Energy. This lesson talks about how pig farms can use their waste to create biogas. Dairy farms all do the same thing. This lesson just focuses on pigs to be simple. But this is a lab that you can do in the class as a demonstration, where you take a water bottle with yeast and sugar in it and connect that to a balloon. So what this is representing is a covered lagoon. So lagoons are places where manure is stored on farms, livestock farms. And so that's the biomass. The manure represents the biomass. And that creates a gas that is trapped inside these digesters where the manure is stored. And then the biogas is then used to power farms and sometimes even nearby areas to produce power for them. This is an activity that you can do. This one is in the carbon hoofprints lesson. But this is a really general idea that you can use in your classroom to talk about any topic that has multiple perspectives. So in the carbon hoofprints lesson, we're talking about cattle in the environment. You can take a beach ball and put numbers on it, like you see on this picture. Stand in the middle of your room and then ask students in varying corners of your room which numbers they see without turning the ball. So one student is going to be able to see all of the 3 and part of the number 2, for example, and another student will see number 6. You use that as a lesson and kind of an illustration for them to realize that everybody has different perspectives, and to learn to listen to different perspectives and to learn to think and reason with what they see and what they hear. Because a lot of what climate change comes down to is being able to synthesize the information that they're given, to see what's in the media, but also to use science to explain it and contextualize it and understand it. Okay, it takes a deeper and larger ability to think through certain claims in the media and to really understand. Because like I said, being agriculturally literate isn't to think that agriculture doesn't contribute to climate change, but it is to recognize that while agriculture does use our natural resources, what are we doing to improve that? And what are we getting from that? You know, what kind of balance can we find in sustainability? So that kind of pulls that together. Something I'd like to encourage everybody to do is just make sure that you're connected through social media with National Ag in the Classroom, as well as your state organization. Each state has an Ag in the Classroom program. So make sure that you find that. And another invitation to give is here at National Ag, or in the National Center for Ag Literacy, we have kind of a tribe of teachers that when we have new lessons that need to be piloted or reviewed, I just have a list of teachers and their subject areas that I would love to have you be a part of that. So for example, if you're AP Human Geography teacher, I'll put you on that list. And when we have a new APHG lesson, then I'll let you know when we have new lessons. And if you're able to pilot them, that will be great. And if not, sometimes we're just looking for feedback. So that is that. You can be added to that list if you'll just email me. And with that, let me look. And does anybody have any questions?
And there were some questions about how to find the lesson. I answered those questions, put that link back in there. If
Okay.
you have any other questions, make sure that you type that in the Q&A just the next few seconds here. Andrea, I want to thank you for these resources. I agree with you in that agricultural literacy helps us hopefully become critical thinkers and asking questions, not necessarily, we're making sure that we understand the facts that are out there and using science, excuse me, to make decisions about agricultural literacy. So again, thank you very much. Again, I'll watch the Q&A here for the next few seconds. So thank you again to all of our presenters today and to our audience and participants. I want to thank you for all that you have done and you've participated. Appreciate your time. We know that summertime is precious. It's very precious. And so we appreciate you being here today and spending your day with us. Again, a very special thank you to the CHS Foundation. I've got some questions here, Andrea. Let's see. Andrea, will you show your email slide again, please?
Yes. Yeah.
Excuse me, Andrea, do you have any tips for, this is the climate change issue is could be a kind of a heavy one. And a person asked, how do you help students get through this when they're bogged down by the enormity of such a huge issue?
It's a good question. I think, like I said, in a lot of the conversation I've had with science teachers when they talk about climate change is just that it just gets very dreary, and so I think if you focus, like the climate smart agriculture topics, I feel like are very positive. I feel like they give them direction of, yes, the climate's changing, and yes, it takes natural resources to produce our food, but look at these ways that we are improving what we're doing. And that's something that we'll need to continue for a long time, almost forever, really. But just kind of focusing on the positive side of that and the progress that we're making in agriculture, I think is helpful.
Thank you. My students, I teach at university level, and they say the same thing. They say this is such a doom and gloom kind of a topic, but it doesn't have to be. And I think you're right. Having students do their own research and read and think critically kind of helps empower them to make some decisions, to know that they are making a difference. So I certainly agree with that. Great questions, excellent questions. So again, thank you everyone who's participated today. Thank you to CHS Foundation for their generous support of sponsoring this webinar today. Make sure you watch your email. Sorry, I'm dealing with the post-COVID here. Make sure you watch your email for an evaluation that's coming from National Agriculture in the Classroom. We'll be drawing door prizes next week, and we will make sure we notify winners via email. So again, watch for that. You can shop on agclassroomstore.com. That's our online store. And through the month of August, you can use the code virtual22 to shop, and we will make sure that we share that information with you via email. So again, watch our website, follow us on social media, National Agriculture in the Classroom, to keep up with future events, future professional development, future conferences, ways to interact and participate with our organization. And with that, we will say goodbye and good day. We wish all of you a very, very successful 2022-23 school year. Thank you very much for your